I give you an equation. X, you try to do this one. X is equal to A plus BT plus C T square plus D TQ upon E plus T. Right? Now you have to find the dimension of A, B, C, D, and E, where we say the X is the displacement, T is the time. So first, did you get the dimension of A?
A will be L.
Yeah, so each term has the same dimension. So we can say, or you can write this equation as X minus A minus B T minus C T square minus D TQ E plus T, right? This is equal to 0. Now we know each term will have the same dimension. Dimension of X will be equal to the dimension of A, which will be equal to the dimension of BT, CT square, and this whole term, right? So now what is the X? X is the displacement. So we know the dimension of X, which is displacement, is given by L, right? So the dimension of A will be what? That will be also L. Now what about B?
L T to the power minus.
Yeah, so the dimension of BT is same as X, or you can say as L, right? So now what is B? B into T. T is the time, right? So that I've taken this one. That gives you L. Now what is B? B will be equal to L T minus 1. So you have got this dimension. So we have got of B, L T minus 1, A L. Now what about C? So CT square is also the dimension of that is equivalent to L, right? So what is the dimension of C? What did you get? L?
T minus 2.
Okay, done. Now what about this? How will you calculate D and E?
Since we are adding E and T, so their dimension should be same.
Yes, so two physical quantities dimension should be same. So E plus T we are adding. So E's dimension will be equal to T. So we have got E dimension as T. Okay. So now what about this D? Now you can find D, right? So how will you find D?
So the T term will be 3 minus 1. So dt square it will be.
Okay. So what are you getting finally?
LT minus 2.
L T to the power?
Minus 2.
Yeah, right. So we have got the dimension of D T cube E plus T, that is equal to the dimension of, you can say dimension of X, which is L, right? Which we got as L, right? So D into the dimension of T cube, that T is the time, so you can T to the power 3 upon E plus T. So that is we have got as T, right? So T gets cancelled. So what is left? D
T square.
T square. So that is equal to L. So what we are getting D? D we have got L T to the power minus 2. So finally we have got all the dimensions. So you have to just be careful, like the if it is X, dimension is L, L and this BT, you have to take the full term, right? Usually students, they do a mistake, right? They take the dimension of X equal to dimension of B, B dimension equal to X, right? So you have to take the whole term. In the equation, all the terms will be having the same dimension, right? So this is based on homogeneity. Now let's see if you can solve some of the questions. Okay, then we'll try out with the first application. What was the first application? To check the correctness of the equation. Okay, let's complete all the 3 topics and then we can start with our worksheet, right? So if I take a simple example of how to check the correctness of the equation. So let us suppose I have to check the equation. The equation is S is equal to UT plus half AT square. This is the very famous equation, right? In laws of motion, S is the displacement that you must be knowing. A is the acceleration, right? And T is the time.